Hello everyone. Good morning. Welcome in online short-term certificate course on vermicomposting technology. I hope you are doing well. I am Professor Vishal Vaidya from Department of Zoology, Gandhi College, Kada. Welcome to today's session on component of the vermicomposting. In our previous session, we learned about the basics of vermicomposting and its benefits. Today, we are deeper what makes up a successful vermicomposting system and understanding the key component that works together to turn organic waste into rich compost. Have you ever wondered why a worm bean needs a certain materials and a specific condition to work effectively? Much like baking a cake require the right ingredient and process. Vermicomposting also depend on combining a component in the right way. Without a proper balance, things can go wrong. Too wet, too dry, evenly smelly. By the end of this session, you will able to identify essential component of vermicomposting system. Understand the role of each component in the computing process and learn how to maintain the right balance to ensure the successful computing. So I'm going to discuss with you the slide one. What composting means the earthworms and the microbes together produce useful manure, that is vermicompost. Earthworms and microorganisms share a mutualistic relationship, better biodegradation and maintenance. A main feature of the vermicompost includes the higher surface area and a low value of carbon to nitrogen ratio. Maximum nutrient availability is necessary, water holding capacity and increased porosity. The earthworm species used for vermicomposting are Fidelia sinensis, the Octogita betex, Digogaster bolevi, Pereniox similensis, Eisenia fetida, Eisenia andrea, Lubricus rubilus, Euryalus eugenie. It is also called as African night crawlers, Pereniox escatus, its Indian blue worm, and Metaphire postuma. Those species actually used in the composting. Those substrate used for the vermicomposting are the best component is a mixture of green and brown material. The green materials are young weeds and plants, fruits and vegetables, tea leaves or cut flowers are the green materials used for the substrate as a substrate in vermicomposting. And the brown material, the fall leaves, the wood and the chips, sawdust, cardboard, those are the brown material used for the substrate in vermicomposting. The process of vermicomposting in that use a plastic or concrete tank prepared a compost size based on raw material. Collect a biomass and dry it in sun 8 to 12 days, then chop it. Now, in the process, again prepare cow dung slurry and sprinkle on biomass for faster decomposition. Add 2 to 3-inch layer of soil or sand at the tank bottom. Create fine bedding with partially decomposed cow dung, dried leaves, and biodegradable waste. Layer chopped bio-waste and cow dung up to zero point 0.5 to 1 feet. Add earthworms to the mixture and cover a dry straw or a gunny bags. Regularly sprinkle water to maintain the moisture level. Cover a tank to protect it from the pest, rain and direct sunlight. Monitor compost to avoid overheating and ensure proper moisture and temperature. The parameter need to check are the temperature, pH and the moisture. Those are very important parameters in the vermicomposting. The organic carbon, it is high before composting and low after the composting. The nitrogen level low before composting and high after the composting. And the phosphorus is low before composting and high after the composting. The potassium level low before the composting, it will high after the composting. The enzymes, they are very low before composting but high after the preparation. The minerals low before composting and high after. Cellulose high before composting and low after. Hemicellulose high before composting and low after because of the composting. The lignin high before composting and low after the composting. So thank you once again.